This naturalrefrigerants.com article is being read by an automated voice. Danfoss Multi-Ejector HP with parallel compression reduces CO2 system energy use by 21%, compared to traditional boosters, by J.O. Haraldson. Published March 11, 2026. Danish component manufacturer Danfoss reported in a white paper that pairing its multi-ejector HP, high pressure, with parallel compression and transcritical CO2 refrigeration reduced energy use by 21% compared to traditional booster systems in 2 U.S. field tests. The company tested its multi-ejector in 2 new supermarkets across different climate zones, a mild environment in the Midwest and a warmer site in the South. The technology capitalizes on the Venturi effect to generate free compression. Test results showed that the Danfoss ejector provided significant energy saving even when ambient roof temperatures exceeded 95 degrees Fahrenheit, 35 degrees Celsius, said Chris Brown, application engineering manager at Danfoss. In cold ambient conditions, the HP ejector serves the same functions as a conventional high-pressure valve, controlling the system at the COP optimum. Danfoss offers a range of ejectors for CO2 refrigeration systems, including models for low-pressure booster systems without parallel compression, high-pressure systems with parallel compression, and liquid ejectors for both configurations. The company first piloted the technology in 2015. To secure UL certification for the device, it started collaborating with US-based OEMs in 2016. How it works. Instead of using a high-pressure valve to reduce the pressure of the CO2 gas leaving the gas cooler, Danfoss's multi-ejector harnesses the expansion energy to produce free compression. High-pressure CO2 gas from the gas cooler is funneled into the ejector, where a narrowed throat accelerates the flow. The gas exits the nozzle at supersonic speed, creating a low-pressure zone and drawing in saturated vapor from the medium-temperature, MT, evaporator suction line. The 2 streams mix in the chamber and are discharged to the parallel compressor, with the kinetic energy of the flow raising the pressure without the need for mechanical compression. U.S. tests. In the 2 pilot cases, Danfoss installed a 6-cartridge multi-ejector HP CTM6 with parallel bypass piping that integrates a redundant high-pressure valve to facilitate comparative testing. A Danfoss controller pack manages the ejector's on/off staging. Refrigeration design included low-temperature compressors with a suction inlet of -15 degrees Fahrenheit, -26 degrees Celsius, at 220 pounds per square inch, 15 bars. MT compressors at 18 degrees Fahrenheit, -7 degrees Celsius, at 395 pounds per square inch, 27 bars. An intermediate compressor at 36 degrees Fahrenheit, 2 degrees Celsius, at 520 pounds per square inch, 36 bars. A receiver at 36 degrees Fahrenheit and 520 pounds per square inch, a flash gas bypass valve, a suction accumulator, and a discharge/gas cooler operating with refrigerant temperatures from 50 to 95 degrees Fahrenheit, 10 to 35 degrees Celsius, at 700 to 1,300 pounds per square inch. 48 to 90 bars. The conclusions: at 95 degrees Fahrenheit ambient conditions, parallel compression reduced energy usage by 8% compared to a traditional CO2 booster system, and the multi-ejector cut energy use by an additional 13.4%, for total savings of 21.4%. Performance gains from the device begin to appear in temperatures as low as 50 degrees Fahrenheit, Danfoss said, adding that the sharpest decrease in energy usage occurs between 65 and 70 degrees Fahrenheit, 18 and 21 degrees Celsius. With stabilized CO2 rack performance, the multi-ejector cuts compressor cycling by as much as 47%, helping to extend equipment life. Quotable: combining parallel compression and an ejector in an integrated system is the special ingredient that gets more useful work from carbon dioxide's refrigeration cycle, said Brown. The solution also potentially reduces compressor cycling and cumulative current inrush, enhancing the reliability of the supermarket's refrigeration system.